Hello and welcome to the University of Manchester. My name is Duncan. In this short video I'm going to be explaining our software engineering mentoring scheme, how you can get involved in it and why you might want to do so, and what we expect from you in return. Our software engineering mentoring scheme is part of our undergraduate scheme in computer science at the University of Manchester. It's actually taught in our second year. So let's start with our students. Our current UCAS entry tariff for undergraduate students is 3 A stars, including mathematics and 1 science subject. During their first year, so the year before this course, they do lots of things in their first year. Two of the most important things in regards to this course are Python and Java. So they spend a year doing introductory programming in Python and Java. So they start their second year, they've got a reasonable grasp of those languages, reasonable competence in that. In the second year, we split them up into about 40 groups of about 8 students, and they work as a team throughout the semester on their software engineering project. An important part of what we're trying to teach here is this isn't really about coding. Obviously, they have to be able to write code in order to do the engineering, but the focus is much more on engineering. How do we build good quality software? How do we write tests? How do we make sure that when we release software, it works, it doesn't go wrong, it doesn't cost our customers or employers lots of money in doing so. So the emphasis is much more on the engineering than it is on the coding, which tends to be the focus of some other courses you might find in computer science. So this is what the course looks like. It's split into 12 weeks, 3 4-week blocks. In the first 4 weeks we teach, so this is starting in September, running through December. We teach Git basics, so they'll have done some Git stuff in first year. They'll be reasonably competent with Git. We recap that and advance that. We then look at automated build and why do you need to do automated builds? Why do you need to automate your tests? What kind of tests do you need to automate and why is that important? We look at code reading techniques because this is a reasonably large code base we're working on. Students need to be thinking about what strategies they're going to be using for reading other people's code. And then we explicitly talk about debugging strategies, how you debug other people's code. So that's the first part. In the second part of the 3 weeks, third rather, of the 12 weeks, we look at working with features. So looking at software estimation, techniques for coming up with reliable estimates for how long a feature is going to take to implement or how long a bug is going to take to fix. We look at different kinds of Git workflows, not just the one that we're using, but other Git workflows that are possible. We look at test-first development, so not really test-driven development, but test-first development, writing the test first in order to find the bugs and identify the problems. And then we do some code review. So the mentoring sessions, the 2 mentoring sessions I'll talk a little bit about later. There's one at the end of the first 4-week period, and then another one 4 weeks later, just over 4 weeks later at the end of the 8-week period. And they are basically code review. The last, third and final part of the course is about larger scale change. So we look at things like design for testability. We look at refactoring, doing some feature migration and looking at some design patterns. And the point of doing this is that we're trying to equip students to, if they choose to, get involved in open source software projects. Is a great way for them to get some experience of building real software that gets used while they're at university. The software itself is written in Java. We're using GitLab for our code repositories rather than GitHub. We need to have private code repositories, and there are other constraints of working in the university that mean we have to use GitLab. We're using Eclipse as our IDE. We're using Apache Ant to do some of the build, and Jenkins to do the continuous integration and continuous development, and JUnit for doing the testing. Now, it doesn't really matter if you're not using these exact tools, or you might think Eclipse is a load of rubbish and no one uses that anymore, or maybe you don't do Java, you do something else. That doesn't really matter. We're not so bothered about the details. It's more about the overarching principles of how you build software at scale. How do you do continuous integration? How do you do continuous development? That kind of stuff. So if you think these tools aren't really aren't what you're using, it doesn't really matter. As I say, it's more about the principles than it is about the specifics of the tools or the language that we're using. The software that our students build and test is something called Stendhal Game. It happens to be a massively multiplayer online role-player game that you can see behind me here. It's open source. It's more than 10,000 lines of code. It has more than 2,000 unit tests to give you an idea of the size. Now that's perhaps not huge compared to some of the code bases perhaps you're working on out there in industry, but it is orders of magnitude larger than many of our students will have seen at this point. So it's quite a challenging project for many of our students. It also has 10 years of legacy. So there's more than 10 years of legacy in the code base. So it's been around for a long time. And an important part of what we're trying to teach is about brownfield development. So in the first year they do a project where they do greenfield. They can do what the hell they want, design what they want using whatever code they want. This is much more constrained problem, a more realistic problem of what software engineering is like in the real world, where you're given somebody else's code base and maybe it's badly written, maybe you don't like it, you just have to deal with it. Perhaps you don't like the architecture, you don't like the style, but that's what you have to work with. It has many users, so it's not a toy project, it's an actual real project, a real game that people play, and is constantly being released and updated. And perhaps like most software engineering projects, it has changing and uncertain requirements. So some of our feature requests and bugs are perhaps not fully specified, and that's an important skill, being able to understand what people mean when they make feature requests or identify bugs. It is a multi-user application because it's a multiplayer game, and in terms of the architecture it's multi-threaded and it's a client-server architecture as well. So it's a reasonably meaty software engineering project for our students to get stuck into. It's not a toy project, it's reasonably big and meaty. So what are we asking you for as a software engineering mentor? We're asking you to be involved in 2 one-hour sessions of what is essentially code review done via Zoom, remotely, online, and we're asking you to share your expertise, your real-world software engineering expertise with our student. That's the real value that our mentors add to the course, and essentially doing code review. Now we're quite flexible about how the code review is done. We give you access to their code repositories, and perhaps for some of them it'll be the first time a professional software engineer has actually looked at their code in any depth. But also the code review can be perhaps sometimes more about the personal and social aspects of working in a team, working with a large code base, working with people perhaps in the same time zone as you, who you only collaborate with online. That's all important stuff. So what's in it for you as a software engineer or as an employer? First thing is it lets students know about your organization. So many of our students will obviously have heard of household names, the blue chip companies, the Facebooks, the Googles, the Microsofts, the Apples, those kinds of companies. And we do have mentors from those companies. But lots of our mentors come from less obvious organizations which our students might not necessarily associate with software engineering. So this is your opportunity to put your company in front of students and say, look, this is us, this is what we do, this is how we build software, and this is how it works with us. It's obviously an opportunity to share your knowledge. So employers are frequently telling universities that in computer science, for example, that they're not teaching the right subjects or they're not teaching them the right things. They come out of university and they're not ready to work in the real world. So this is your opportunity to change that, to raise the bar and make sure that more students are more ready for the workplace when they graduate. Many of our software engineers are junior. We have senior software engineers and junior software engineers on the mentoring program. For junior software engineers, we think it's a good thing for career development because if you're a junior software engineer joining an organization, there's not very many people beneath you who you can, below your junior engineers beneath you who you can mentor. So this is an opportunity for early career engineers to get involved in doing that and have that on their CV as they progress in their careers. And then last but not least, it is fun, it's enjoyable, working with students on these projects as they navigate this large project, and not just the technicalities of it, but also the politics of it as well. So that's fun. Many of our mentors are involved in the program just because they enjoy doing it. In the case where we're oversubscribed, so there will be details at the end of how you can get involved in this. if we are oversubscribed, if we manage to recruit more mentors, that sometimes happens, we will prioritise the following things. So we would like more women, although our industry is not gender balanced, we'd like to have more women mentors. We have plenty of female software engineers, and we would like to provide them with female role models where possible. Returning mentors will also get higher priority. So if you've come from an organisation that has been involved in this in the past, or you've been involved in it yourself, those mentors will tend to get priority. So that's it. Thank you for listening. Thank you to all of our mentors from all of these organisations you can see behind me here who've been involved since this programme started 6 years ago. We're very grateful, firstly for their guidance in setting up this course when it started, but also in their support in providing mentors throughout this course. It's not been possible to run this course without lots of collaboration with lots of software engineers working in industry. I should also thank Suzanne Embry, who is actually the brains and leader of this course, and a large team of people who've been involved in, including myself, been involved in delivering and running this course with Suzanne. And that also includes more than 2,000 students who've done this course since it started back in 2016. So thank you to them. So you can find out more if you're interested. The first link is a generic link that describes some of the things I've been talking about here. If you go to man.ac.uk/LGS1VX, that's got the details. There's also our lab manual at softwareeng.netlify.app. There's a /mentors there, which has a sign-up link on Zoom, which if you ask you for your name and email address and then you register, you get a calendar invite to when the first session is. Thank you for listening. If you have any questions or comments, you can contact me using those details below, and we look forward to hearing from you soon.